Hi guys, here are your notes on 4.2 trig functions of the unit circle. So once you're done watching this video, you should be able to find the 6 trig ratios of a point on the unit circle and use the formula for negative angles. So we have already built the unit circle, so now we can use the unit circle to be able to find exact values of trig functions. So if you have a point that is on the unit circle, we can let theta equal t, where the angle is in between 0 and 2 pi. So it's between 0 and 2 pi. So when that's the case, cosine of your angle represents the x-coordinate of that particular point. Sine of your angle represents the y-coordinate. So another way that I can write this xy coordinate on this drawing over here is I can write that as cosine of theta, sine of theta. So cosine is your x, sine is your y coordinate. Tangent is y over x. So tangent uses both coordinates, and that's y over x. The secant, cosecant, and cotangent, those are reciprocal functions of sine, cosine, and tangent. So cosine and secant go together. So cosine is x, so that means secant is 1 over x. Sine and cosecant go together, so since sine is y, cosecant will be 1 over y. And then tangent and cotangent go together, so if tangent is y over x, that means cotangent is x over y. So for the first example, I'm giving you a point that is on the unit circle. Now the 3/5 and negative 4/5 is not on the unit circle that we drew yesterday, but there's an infinite amount of ordered pairs on that unit circle, not just the specific ones that we plotted. And 3/5 and negative 4/5 is one of them. So I'm going to find all 6 trig functions at t. So I have my cosine of t, my sine of t, and my tangent of t. So I start with the regular trig functions first. So cosine is your x-coordinate. Well, my x-coordinate of my point is 3/5. So cosine of t is 3/5. Sine is my y-coordinate, so my y-coordinate is negative 4/5. Tangent is y over x. So I have negative 4/5 divided by 3/5. Now, since these denominators are exactly the same, those denominators are going to cancel. So that means tangent is negative 4/3. Since I know cosine, sine, and tangent, I can go ahead and find secant, cosecant, and cotangent. So cosine matches up with secant. Try not to make the mistake of matching up cosine with cosecant, because those two actually aren't reciprocals of each other. Cosine matches up with secant. So since cosine is 3/5, that means secant is 5/3, because they're reciprocals. Sine gets matched up with cosecant, and since sine is negative 4/5, that means cosecant is negative 5/4. And then cotangent matches up with tangent, and since cotangent is negative 4/3, that means since tangent is negative 4/3, that means cotangent is negative 3/4. I think I initially said that backwards. But those are the 6 trig functions when I give you the point. Cosine's your x, sine is your y, tangent is y over x. And then you can just flip those suckers over to get secant, cosecant, and cotangent. Now the next thing that we're looking at is finding the 6 trig ratios of angle measurements that are actually on the unit circle. So there is a video that I posted on Canvas of creating the unit circle as well as using the hand trick to find these coordinates around the unit circle. If you have not watched the video for the hand trick, I would highly recommend that you do it, because that'll help you get the points, the coordinates, at pi over 6 and negative 4 pi over 3 without actually having to reference the unit circle. So pi over 6, if I use my hand trick, pi over 6 is going to be represented by 30 degrees, since pi over 6 is equivalent to 30 degrees. So I'm going to put down my ring finger, and if you have not watched the video for the hand trick, you have no idea what I'm talking about right now. But my coordinates for pi over 6 is going to be root 3 over 2 and 1/2. And this I'm getting just by looking at my left hand, which you can too if you watch the video for the hand trick. Okay, so once I have my coordinates, finding the values of the 6 trig functions is exactly like you did with the other example. So my cosine is my x-coordinate, so root 3 over 2. Sine is my y-coordinate, so 1/2. And tangent is y over x, so I have 1/2 over root 3 over 2. Since those denominators are the same, they can cancel. So that leaves me with 1 over root 3. Can't really have radicals in the denominator, so that gets changed to root 3 over 3. If you don't know where I got root 3 over 3 from, I can take 1 over root 3 and multiply it by root 3 over root 3. That'll get rid of the radical in the denominator. Okay, now that I know cosine, sine, and tangent, I can find secant. So secant will be 2 over root 3. Which again, you can't have radicals in the denominator, so that becomes 2 root 3 over 3. Cosecant matches up with sine, and since sine is 1/2, cosecant is 2. And cotangent matches up with tangent, so I'm going to take the reciprocal of tangent. Now when I take the reciprocal of tangent, I'm actually going to take the reciprocal of this, because once I take the reciprocal of 1 over root 3, that just leaves me with root 3 over 1. And then I don't have to worry about changing it again. So here are the 6 trig functions when your angle is at pi over 6 radians. Alright. So negative angles, I want to find a positive coterminal angle first. So I'm going to take negative 4 pi over 3 plus 2 pi. That gives me 2 pi over 3. Now 2 pi over 3 can't be used with the hand trick because your angle measurements for your hand trick are pi over 6, pi over 4, and pi over 3. So with 2 pi over 3, I need to find the reference angle first. So I'm going to sketch out 2 pi over 3. There's 0 and pi. 2 pi over 3 is closer to pi than it is to 0. So that puts us in that second quadrant. And this right here is your reference angle. So I need to figure out how much further I need to go to get to pi from 2 pi over 3. That's pi over 3. So my reference angle is pi over 3. So I can go ahead and use my hand trick. I'm going to put down my index finger since that's pi over 3 on my hand trick. And my ordered pair is 1/2, comma, root 3 over 2. Now keep in mind, the hand trick gives you all the angle measurements in the first quadrant. But this angle measurement was actually in the second quadrant. And in the second quadrant, when I look at my ordered pairs, my second quadrant has negative x's with positive y's. So I can go ahead and take that ordered pair and make my x negative, and my y is going to stay positive. And once I get my ordered pair, I can go ahead and find those 6 trig functions. So cosine's my x-coordinate. So cosine's negative 1/2. Sine is my y-coordinate, which is root 3 over 2. And tangent is y over x, so root 3 over 2 over negative 1/2. Denominators are the same, so they cancel. So that leaves me with negative root 3. Since cosine is negative 1/2, that means secant is -2. Since sine is √3/2, that means cosecant is 2/√3, but you can't have radicals in the denominator, so that's 2√3/3. And tangent is -√3, so that means cotangent is 1/√3, but you can't have radicals in the denominator, so that's -√3/3. And these are the 6 trig functions at those particular angles on the unit circle. So again, if you do not understand where these ordered pairs come from, you need to watch that video on the hand trig. Okay, the next thing we're looking at is finding a point relative to a given point. So let P of t be the point on the unit circle U that corresponds to t. If P of t has a given coordinates, -3/5 and 4/5, find each of these values. So I'm actually going to graph where this point would be. So -3/5 with the +4/5 is over here. Right, because my x is negative and my y is positive. Now what you're looking at for letter A is you're taking your angle measurement plus pi. Now pi is equivalent to 180 degrees. So 180 degrees, or pi, is equivalent to half of a rotation. So when I look at my drawing, I'm going to go ahead and redraw it over here. There's my point. What I'm doing is I'm taking that point and rotating it half of a rotation. So now my point's over here. So I've gone from the second quadrant to the fourth quadrant, so I just need to adjust the signs accordingly. So where my x was originally negative, it's now positive, and my y is now negative. Because in that fourth quadrant, my x is positive, y is negative. So it's helpful to see where your actual angle is, because that's going to determine the signs that you use. For letter B, I'm going to do the same thing. I'm going to look at my original sketch. There's my point. And I am subtracting pi, so that means I'm going half of a rotation in the opposite direction. But if you notice, that still lands you in that fourth quadrant, where your x is positive, y is negative. I don't know why I put a 1 there, it should be negative. So I'm just going to adjust that point accordingly. So that becomes positive 3/5 with a negative 4/5, just like you had for letter A. Now a negative P of t means you're going clockwise instead of counterclockwise. So your angle is this right there. That's the positive angle t. So for the negative angle t, I'm going to go in the opposite direction. So that lands you in the third quadrant. In the third quadrant, both of your coordinates are negative, so I can go ahead and adjust that point accordingly. So now I'm at -3/5 with a -4/5. So it's helpful if you draw your original point and then just do the rotations as they are stated within those parentheses with t. Now letter C actually leads us into the next part of our notes, which is looking at negative angle measurements. So we have these formulas for negative angles. So if I have sine of negative t, that's the same thing as negative sine of positive t. If I have cosine of negative t, that's the same thing as cosine of positive t. If I have tangent of negative t, that's the same thing as negative tangent of t. And here's why that works. Let's say I have my original angle over here, just like we did with the last example. And I am looking at negative t, which is going in the opposite direction. So my original point had the coordinates negative, positive. My new point has the coordinates negative, negative. So sine is your y-coordinate. So if you'll notice, my y-coordinate switched signs. It went from positive to negative, which is why over here it ends up switching signs. Cosine is my x-coordinate, and your x-coordinate stayed the same sign, which is why cosine of negative t is equivalent to cosine of regular t. And then tangent is y over x. So if I look at taking my y-coordinate divided by my x-coordinate of my original point, positive, divided by a negative is negative. Negative divided by a negative is positive. So my new point ends up switching signs. And cosecant, secant, and cotangent are just reciprocals of the original 3 trig functions, so your formulas for negative angles would be the same. Okay, so let's use the formula for negatives to find the exact value. So sine of negative 30 degrees, that is equal to negative sine of positive 30 degrees, since it switches signs. So I need to find sine of 30 degrees first, so I'm going to use my little hand trick. 30 degrees is equivalent to your ring finger, so I'm going to put down my ring finger. Sine is my y-coordinate, so my y-coordinate is 1 over 2. So I have negative 1 over 2. Again, watch that video on the hand trick if you have no idea what I'm talking about. Okay, secant matches up with cosine, and cosine of a negative angle is equivalent to cosine of the positive angle. So secant of negative 45 degrees is equivalent to secant of positive 45 degrees. So 45 degrees is my middle finger. I'm going to go ahead and put down my middle finger. Secant matches up with your x-coordinate. So my x-coordinate is root 2 over 2. So I'm actually finding cosine right now. Cosine of 45 degrees first, and that's root 2 over 2. And the reason why I'm finding cosine first is because secant is the reciprocal of that. So now I can take that root 2 over 2 and flip it over. And that gives me 2 over root 2. Can't have radicals in the denominator. So that's 2 root 2 over 2, which is just root 2. And then tangent of a negative angle is equivalent to negative tangent of the positive angle. So tangent at pi over 6 is equivalent to my ring finger, and it's my y-coordinate divided by my x-coordinate, so my y-coordinate is 1/2 divided by my x-coordinate, which is root 3 over 2. Denominators are the same, so they cancel. So that leaves you with negative 1 over root 3. But again, can't have radicals in the denominator. So that's negative root 3 over 3. So there are the exact values of the negative angles. Okay, the last thing we're looking at is just plugging stuff into the calculator. So when you're plugging stuff into the calculator, you do need to double check your mode. So let's make a note. Check the mode. Because sometimes your angles will be in degrees, sometimes they will be in radians. So whenever you see a pi, it's going to be in radians, also because you don't have a degree symbol. So that negative pi over 7 is in radians. And that 1.75 is also in radians because you don't have a degree symbol. So I'm going to hit mode on my calculator, and I want to make sure the word radian is highlighted since I need to calculate these in radians. And then for tangent of negative pi over 7, I'm literally just going to type it in. I'm going to type in tangent. Negative pi is right above your exponent key underneath clear. Pi divided by 7. And let's go to 3 decimal places. So that is negative 0.482. And cosecant. So your calculator doesn't actually have a cosecant button, but it does have the reciprocal of cosecant, which is sine. So what I can do is I can find sine of 1.75, and cosecant is the reciprocal of that. So this is what I'm plugging into the calculator. It's 1 over sine of 1.75. So anytime I give you a trig function that is not sine, cosine, or tangent, so I give you cosecant, secant, or cotangent, you can take 1 over the original trig function and plug that into the calculator. So 1 divided by sine of 1.75 gives you 1.016. Alright, so that concludes your notes for section, I forgot what section this was, 4.2.